Hello students, welcome to Nilachal Polytechnic. Myself Amarendra Mishra. I am continuing with the video lecture class on chapter number 4 of Fluid Mechanics subject. Here in this video, I am going to explain about the discharge and continuity equation of fluid. Let's discuss about the discharge. In practical life, we are going to see that the liquid is flowing through the pipe. What much amount of water is flowing through the pipe, it is required to be measured. So for that reason, the concept of discharge is formed. It is defined as the quantity of fluid flowing per second through a section of a pipe or a channel. We know that there are two types of fluid. One is incompressible fluid, another is compressible fluids. The incompressible fluids are known as liquids, where the definition is found as the volume of liquid flowing per second. Similarly, for gases or compressible fluids, it is expressed as the weight of fluid flowing per second across a section. It is denoted by symbol Q. For liquid, it is volume per second, hence your unit is meter cube per second or 1 liters per second. 1 liters is equal to 1000 meter cube per second. For gases, it is force per time, so unit is Newton per second, and also we can say that kgf per second. The unit of discharge is that meter cube per second and Newton per second. Now let's come to the continuity equation. The continuity equation statement as it states that for a perfect incompressible fluid flowing continuously from one section to another, the rate of flow of fluid is same at any section in its path of flow, provided no fluid is added to or subtracted from flowing liquid. The continuity equation states the conservation of mass, law of conservation of mass, where the mass of or the quantity of liquid flowing per second at the inlet and outlet of the pipe remains constant. Now go for the proof of continuity equation. For the proof of continuity equation, let's consider a pipe as shown in the diagram. There are two sections, one is inlet section, another is outlet section. The fluid flow is given by the arrow mark or direction is given that inlet means entry of liquid, outlet means this is moving of liquid out from the pipe. Let us consider the flow parameters like pressure, velocity and area is P1, V1, A1. At outlet, it is P2, V2, A2. This is the corresponding value of pressure, velocity and area per section of the pipe at outlet. So, according to continuity equation, we know that mass of liquid flowing per second at inlet is equal to mass of liquid flowing per second at the outlet. That means m dot 1 is equal to m dot 2. We know that density is equal to mass per volume. Now mass is equal to density into volume. Density into volume means that is rho 1 into A1 L1 means A1 is your area, L is your length. So A1 L1 is equal to V1. Similarly, A2 L2 is your V2 at outlet. The mass of liquid flowing per second at inlet is rho 1 A1 L1 by T equal to mass of liquid flowing per second at outlet, it is rho 2 A2 L2 by T. We know that L1 by T is velocity at inlet, L2 by T velocity at outlet. Now the expression reduced to rho 1 A1 V1 is equal to rho 2 A2 V2. So this is your continuity equation. We are having two types of fluid. One is compressible fluid, another is your incompressible fluid. So for compressible fluid, it is rho of liquid or density of liquid does not remain constant. So we are going to consider the value of rho 1 and rho 2. But in case of incompressible fluid, the density remains constant. So rho 1 is equal to rho 2. So it is neglected, and the final continuity equation is reduced to A1 V1 is equal to A2 V2. Here it is concluded that continuity equation, discharge at inlet is Q1, discharge at outlet is Q2. Now Q1 is equal to Q2, that is A1 V1 is equal to A2 V2. The discharge depends upon the area and velocity, where area of cross section of pipe increases, velocity decreases. Area of cross section of pipe decreases, then velocity increases. So while solving problem related to continuity equation, we have to remember that A1 V1 is equal to A2 V2, where A1, that is your area of cross section of pipe at inlet, A2 area of cross section of pipe at outlet, V1 velocity at inlet, V2 velocity of flow at outlet. Thank you.